Welcome to another episode of the Super Data Science Podcast. I'm your host, John Krohn. Today I've got not one, but two guests for you named Ish and Shirish. I am not making that up. Both Ish and Shirish are senior leaders at Dell. And not only are they extremely knowledgeable, this episode is packed with fascinating, actionable facts about AI hardware considerations, including cloud versus local, and what workloads are best suited to CPUs versus GPUs versus NPUs, neural processing units. In addition to all that knowledge that they provide, they are also both very entertaining and play off each other in funny ways. This episode is critical listening for anyone working on training or deploying AI. Enjoy. This episode of Super Data Science is made possible by AWS and the Open Data Science Conference. Welcome to the Super Data Science Podcast. I'm joined by two people today. So I've got Ish and Shirish. So a lot of ishiness happening today.
I'm going to take that, John. That's mine now. You can't have that.
Yeah, and that's Ish speaking right there. Shirish described Ish as his more flamboyant sounding version. So if that helps you distinguish their voices through this episode, we can try that. I'm also going to have them introduce themselves briefly to give you a bit of a sense of who they are. So some listeners may actually already be familiar with Shirish. Shirish was in episode 877 of this podcast. Shirish, welcome back to the show. Where are you calling in from today?
Great to be back, John. I am calling from our headquarters in Round Rock, Texas.
Yeah, Dell headquarters in Round Rock, Texas. And so you're a director of product management at Dell. You've been there for like 22 years or something like
Almost.
that? Wow. And basically in Round Rock that whole time?
Yes, I've been in the Austin area for the entire duration.
Wow. Nice stability there. Ish, you have not quite been there as long.
No.
You've been at Dell for 4 years. You have a title that honestly I don't understand what it means. You're gonna have to.
Most days I don't either. It's okay.
Head of CTO pursuits.
Yes, sir.
For client devices.
It's a really fun way of saying I get to work with people who, very fortunately for me, are way smarter than I am. This is a really good example. I like to joke that Shirish is the evolved Pokemon version of Ish, and I think that that's true for pretty much everyone that I work with out of the CTO Pursuits team, because it's about getting in the field, forward deployed engineering style, roll up your sleeves, find a problem, help someone solve it. Kind of going beyond the whole, we're going to sell you some laptops vibes that maybe some people know Dell for. We've got this whole new function that we're stood up, and there's some really, really talented people helping solve some really, really complicated problems. So it's been a lot of fun for me.
Nice. Well, I think you're downplaying it a little bit. You have achieved some things in the past that make me think that there's some intellect happening around on your side there, Ish. So you have an MBA from MIT, and you were a consultant at BCG before being at Dell. Those are
these are all my dark, dirty laundry things I don't bring up, John. Here we are. Here's the consultant for you all. I just saw the viewership number crash to 0. It's okay. And I love saying, I adored my time at Sloan, but very much, kind of our fake MIT sometimes. I was schooled frequently by some of our visitors from the other courses, as majors are called at MIT. So yeah, it was great. I hope my mom listens to this episode. I think I'm going to get some kudos I very sorely deserve.
Nice. All right. Well, so let's get into, now that our listeners are hopefully familiar with the voices of Ish and Shirish, we can get into the content of today's episode. So Dell famously makes PCs. It's one of the things, that, if not the thing, that Dell is probably best known for. And so the first question that I would like to kick things off with is, for our listeners who are interested in data science, AI applications, a lot of open source, the first thing that might come to a lot of listeners' mind is Unix-based systems. And so why should somebody be considering a PC instead, in particularly maybe even a Windows machine?
Yeah. Well, let me go first, and Ish will have his take on it as well. I would say that you have to start with, what are your objectives, right? If you look at the data science and, the software development community at large, let's just look at the facts. Windows is still the most popular OS for software devs, right? It's about 64%, the last time I checked, of software devs use Windows for development, which is still the leading number out of all of the OS platforms. It is, yes, the standard in the enterprise and for consumers on PCs. So it's familiar, it's friendly, user friendly, great for beginners in the data science field. It's compatible with popular apps, right? Who doesn't want to use productivity apps? There's other data manipulation and visualization apps that run better on Windows. And then at the end of the day, it's, as I said, it's a standard in the enterprise. So if I'm thinking from an IT management perspective, you get the the enterprise security integrations are much more easy, right, with Windows. But that's not it, right? Because let's not kid ourselves. I think if you look at large ML and data science deployments, I think 96% of them are still running on Linux-based or Unix-based servers. So if you are doing large deployments, Linux is probably still the platform that you want to be developing in, because best practices, you want to be developing on the platform that is being used for production environments, right? But I would say at the same time, there's an alternative, right? There's Windows subsystem for Linux. And WSL2 specifically, I think starts closing the gap, right? In all of those scenarios, right? Because you can run a Linux kernel directly on Windows. So if you have Ubuntu running natively, guess what? You now have all of your Linux command line tools that you can run right there on Windows. And so you have best of both worlds. You have all your productivity and other ease of use benefits on Windows, and you don't lose all of the benefits you get working with Linux for data science solutions. So I think that is something that's worth considering. I think WSL's use is still pretty small out there today, but that's an alternative, right? For someone who's on Linux, used to Linux, and wanting to bridge the gap, right? Then last but not least, this is something I touched on briefly in our last episode, John. If you're building for PCs, if you're building apps for PCs, software developers, it goes back to the same best practice. You want to be building in the environment that you're going to have your apps in production. You want to be building in Windows, right? Let's look at the number: 60 million PCs with Linux, 1.6 billion PCs with Windows. That's less than 3% Linux, right? So, and you get all your IDEs, VS Code, Visual Studio, PyCharm, IntelliJ IDEA, etc. That all run natively on Windows. So, it sounds like I'm making a case for Windows here. I'm not a not a Microsoft employee, but I have to say, at the end of the day, it comes down to what you want to do, right? There's a place for Linux for data scientists, and there's a place for Windows.
Yeah, that was really well argued, Shirish. Thank you. It seems kind of like I went to Oxford University for my PhD, and they have something called the Oxford Union there, which is a debate club. And I went and watched some of their debates. And that sounded like kind of opening remarks. So you have all the stats, very compelling argument. Ish, what do you have to say? Are you on the other side of the argument?
I think mine is probably a lot less articulate because it's basically por qué no los dos. Like, it's why pick one thing when you don't have to pick one thing, right? It's with WSL, it's like, what do you need? Just kick into it. There is no dual boot. It's just sort of in the same space. And it's a very fluid transition back and forth. Like, you can bop around in WSL and Windows as you need. And I'm using very technical terms here. But I think the biggest thing is, you can hit a nail with a wrench, but why would you if you have a hammer, right? Like, you've got the right tool for the right job at the right time. And I think that's going to be a theme in this conversation, John. Like, it's Dell's whole point of value in this whole brave new world we live in is choice. It's like, you get to decide what you want to do. You want to throw Linux on your device? Do it. You want to do Windows on your device? Do it. You want both? Do that too. Whatever works for you.
Awesome. Speaking of that idea of being able to have your cake and eat it too, I'm going to butcher the Spanish that you so well said there. Porque
no los dos. Why not both?
Porque no los dos. Yes. And so on the theme of that, I'd like to talk about how your machines, how Dell machines are so supportive of all different kinds of hardware. So not just CPUs, not just GPUs, but NPUs as well, neural processing units, and allowing all three of these to work together. So Shirish, in your previous episode on my show, in episode 877, you began with a really brilliant explanation of what NPUs, neural processing units, are, since that's something that maybe listeners, if they haven't listened to that episode, they should probably get at least a short intro to that. I'd love to hear a bit about NPUs, and then maybe we can also talk about CPUs, GPUs, and the different kinds of situations where you would use those. We'll get to that next. Let's just start with what NPUs are.
Yeah. So, I do encourage everyone to look at or listen to episode 877, where I do cover that in detail, as John said. But for those who are coming in to this cold, an NPU is stands for a neural processing unit, and it's integrated into. Actually, I'll step back. There's two ways you can have access to an NPU. You can have it either integrated into the chipset, or it can be a discrete card that you either put into a slot in the PC or in a built into a mobile device, but it's still a discrete card. So you have both flavors of NPUs. Um, at the end of the day, what sets them apart from the architectures that we've had for maybe more than a decade at least is that they are purpose built to handle AI and ML workloads, right? So that vector math, that is such a foundational aspect of neural networks. Um, the NPU architectures are almost hard coded to handle those workloads. So what you get as a result of that is a much more efficient, processing engine. You don't, especially important for a mobile device where battery life is pretty important, right? The last thing you want is these new workloads that are running on the PC, um, and they tank your battery life. If your battery only lasts half of what it normally does, that's a no go, no bueno, right? So NPUs fulfill that. It's performance per watt is what you get from the NPU for AI ML processing.
Nice. So it's optimized for the kinds of matrix multiplication operations, neural network architectures that are so common in everything, transformer architectures. And so therefore all of the large language models, most of the AI capabilities that we have today can run more efficiently, and especially, as you said there, in a more conservational power way, a more efficient way, on mobile devices. But I mean, even on a laptop, even on a desktop, a server, I'm sure that those improved efficiencies make everything run along more smoothly.
I think if you go back to like kind of the comp sci 101, like think about the logic gates, think about like the levels of abstraction, and think about how a computer does what it does. How does a computer compute? We've been having these debates around x86 and ARM and even RISC, right? The whole RISC-V project. Like the way that these things flow through the transistors on the device. How are you organizing those transistors on the device and on the chip? And this is the natural evolution of, hey, I've got a CPU, it's really good at this. I've got a GPU, it's really good at this. Now there's this new thing, and this new thing is an AI workload, and the way that that runs through those transistors is like different than the rest of the stuff, right? And I know there's going to be people in the comments being like, oh, it's just a current through a thing. Like, yes, we know, but you understand the point, which is that there is a correct tool for a particular job at a particular time. That's not to say that GPUs and CPUs can't run AI workloads. Of course they do. And they do it tremendously well. And there are entire organizations and companies and startups dedicated to how can I get an AI workload to inference really, really well on the CPU? How can I get it to run more power efficiently on the GPU? And then there are people who will skip that process entirely and say, well, if I've got a purpose-built chip, and the reason Shirish paused when he was describing what an NPU was is because, John, the last time he talked to you, he couldn't tell you something that is now true, which is that Dell has announced a device that has a discrete NPU in it. So it's not just on the SoC. And it is a big honking thing that we put into a laptop chassis just because we could. But I think that right now, what used to be a very easy matrix, and a very easy matrix for data scientists to understand, IT decision makers to understand, IT buyers to understand, 2 by 2. I've got this many companies making this many things, and I can pick from this matrix. That matrix has gone from 2 by 2 to like 8 by 8. And now there's this like, who needs what tool for what purpose? And it's a really complicated question. Whereas 2 years ago, it was like, well, what's the newest thing on the menu? I'll take that. It's not so simple anymore.
Curious about Trainium 2, the latest AI chip purpose-built by AWS for large-scale training and inference? Each Trainium 2 instance packs a punch with 20.8 petaflops of compute power, but here's where things get really exciting. The new Trainium 2 Ultra servers combine 64 chips to deliver a massive 83 petaflops in a single node. These Trainium 2 instances deliver 30 to 40% better price performance relative to GPU alternatives. Major players in AI like Anthropic and Databricks, along with innovative startups like Poolside, have teamed up with AWS to power their next-gen AI projects on Trainium 2. Want to see what Trainium 2 can do for your AI workloads? Check out the links in the show notes. All right, now back to the show. Right. Okay, so this sounds pretty exciting, what you're talking about there with having a discrete NPU. Correct me if I completely butcher the
No,
way
you
I'm
got
explaining
it.
this, but
That's
so a
right.
discrete NPU on a laptop. And so if somebody wants to get that, how do they find that? Like, how do they search for that? I can have it in the show notes. This is something that like Dell sells that they can just buy. And why specifically? You talk about this 8 by 8 matrix.
Mhm.
Why should a listener be interested in getting a laptop with a standalone with a discrete NPU?
Yeah, I'll tell you that the most requested device out of our CTO team right now for like their next device refresh within Dell, everyone is on our boss about, I want one of those, and he's like, yeah, we really got to think about how many of these we can get for you guys. But it's the Dell Pro Max mobile workstation, and it has a discrete NPU device coming to it, and it's the CPU is also powered by an Intel chipset, so it's a very interesting machine, and it's not for everyone. Like everyone listening to this podcast, well, actually, maybe this is a pretty biased sample. Maybe everybody listening to this podcast is going to want one and will find a use for it. But think of these specialty devices, right? Think about the GB10 and GB300 coming out from NVIDIA not too long in the future. When we launch this Dell Pro Max, it's just it's another beast. And it's like the right person will want that versus something else. A very cool demo that we ran on this device at Dell Tech World not too long ago. We took a model that Northwestern Medicine had fine-tuned and trained. It's their Ares model, which does imaging, CT scans, X-rays, all done in-house, by the way. Dr. Mozzie and his team over there, shout out to them because they are the true mad scientists. And it was a demo that we worked on with them, and we ran inference on a colonoscopy video, which we blurred out, but a colonoscopy video that inferenced live, like in front of you on that device. No internet uplink needed, no queuing, no waiting at a server somewhere to be processed and to be shipped back. So the question of like, who would want one of these things? Hey, if you've got this sort of specialized use case, or say you live in a part of the world where there are like restrictions on what you can and can't send to the cloud and in which circumstances you can, this kind of device is going to change the game because it has that level of performance and speed that you just 6 months ago, 12 months ago, the last time Shirish was on this podcast, you didn't have that option, right? So it's coming out soon, not out yet, but yes, if you look for the Dell Pro Max with discrete NPU, you will see the press about it.
And sorry, just really quickly, Shirish, the name was Dell Pro Max something workstation. What was it?
So it'll be on the Dell Pro Max Plus devices. It will be, as Ish said, it will be available in the second half of, well, I should say Q4 now at this point.
Yeah, I mean, I guess
More to
both are
come.
true.
More to come.
Okay, that's
Yeah.
cool. All right, I might not exactly be able to include a link in the show notes. I'm not sure. I'll do my best, but regardless, people listening in the future will be able to either find it by looking it up, or they will be able to find it soon. Cool. And sorry, Shirish, I interrupted you. Please.
I was going to say that, and Ish can correct me here, but what's incredible about it is that we could also run 109 billion parameter Llama Scout speculative decoding uh, at FP16 on this card, which is insane. So think of that running locally and the things you can do with it. This is really opens up a lot of use cases that can become viable for on-device inferencing.
Does this mean are you able to kind of give an estimate of like the number of parameters of an LLM you'd be able to fit on there?
Yeah. So 109 billion parameter Llama 4 Scout, right? But that's a speculative decoding model at FP16 cloud native resolution.
Nice. And Ish, it sounded like you had something to add.
No, only that, yeah, it's a pretty big honking model to put on the laptop.
Yeah.
Like,
Oh yeah.
again, me taking a very sophisticated comment from Shirish and distilling it down to base components here. This is bigger than anything you've played around with in anything LLM or LM Studio or Olama to date. Like, this is a, today you just call it, kind of a cloud quality model, right?
Yeah, it is. Not long ago, I remember sitting in meetings with data science teams that I manage, where I would be trying to encourage them to be thinking about using 13 billion parameter llama models, for example, because that was about as large as we could fit on a GPU. And so that's pretty wild to be thinking about something that's almost 10x that size running on a laptop.
Yeah, and
Uh,
more to come, Like this is sort of the progress that's been made in 2025 alone, and it's just staggering to see both the models getting smaller and the hardware getting more capable. Like those two curves, those two things are converging on each other, and it's not going to be one or the other. They're both going to happen together.
Very exciting. So you've mentioned we've now talked about NPUs in some detail now. You've mentioned GPUs. What is the key difference between a GPU and an NPU? It sounds like today a lot of people would be using a GPU for all the workloads that you've been describing. We should actually be using an NPU for.
GPUs integrated and discrete, right, Shrish?
Yeah. So, I'd say that GPUs are far more versatile today, right? Because they're ultimately the best at parallel processing. And so, by definition, they're very performant at AI and ML workloads, right? And we all know that because that's before the advent of the NPUs. That is the accelerator of primary value when it came to AI and ML. The point I was going to make is what really sets GPUs apart is their ability um, to scale in performance, right, relative to NPUs today. If you go back to what Ish was talking about earlier, also the GB10 and the GB300 that have the NVIDIA GPUs that are also coming out later this year, there's some pretty staggering capabilities within those boxes, right? So, like the GB10, for example, is going to be capable of up to a 200 billion parameter model that can be fine tuned locally, which is game changing for your data science community. Now you don't have to set up a whole cloud instance. You have this appliance and your work group in a lab, and you're on business, right? You can really play with some of the frontier models. So that's pretty game changing, and that's fairly accessible from a price standpoint. But I won't go into the details, but it's definitely more affordable than some of the alternatives, right? And then if you really want to scale that up, you have the GB300, which gets you up to 500 billion parameter models at 20 petaflops. But that's at a much different price point, right? So again, it comes down to what you want to do. But GPUs today have far more scale in terms of performance than NPUs. NPUs are still evolving. I think we're talking about first couple of generations. So as Ish said, they're going to get better. Um, and the differentiator for NPUs is performance per watt. GPUs are not that, you know, um, conscious when it comes to power consumption, let me say.
And that's a really nuanced difference, right? For GPUs right now, and we're talking about client devices here, right? Like there is a whole aspect to Dell that is in the server land. It lives up in the cloud, on-prem, hyperscale, whatever you want to do. But on client devices, the highest ceiling right now, GPU. On client devices, the best efficiency right now, CPU or NPU, depending on your use case, right? Speed also depends. What kind of model are you running also depends. And this is that matrix I was talking about, John. Like, it went from, fairly evident what you needed to do to, hey, I'm now thinking about buying a device here in August of 2025 or September of 2025. And I'm trying to figure out what the commitment of this device is going to be over 4 or 5 years, right? I mean, you can really see that lacking something with an NPU in it or lacking something with a discrete GPU in it, you may come to realize that you're going to need to upgrade sooner rather than later if you don't make that investment now. And, Shirish and I, not part of sales. So, like, you buy one laptop, you buy a million, doesn't really impact us, but that's the truth. And that's what I'd think about if I were making a purchase right now.
Right. So let's talk about that next in terms of the kinds of things that people should be looking for if they want to be future proofing for the next 5 years. What are the things? What are the kinds of parameters? Let's go over an 8x8 matrix
Yeah,
in an
no, thank you.
audio only podcast. But, just kind of generally, let's talk about the kinds of things that people should be looking for in hardware that they're buying today. And I guess, as you said, this is specifically about what you described as client devices. And so I'm assuming that isn't a term that I use in my kind of day-to-day language, but it seems to me like that's distinguishing against like servers. It's like laptops, desktops, that
Yeah,
kind of thing.
most normal people aren't running around saying client devices. That is a very Dell
Yes.
kind of term. When you think about what to buy right now, like if I were, if I were starting college or if I were doing something, wow, God, that was a while back. If I was starting college today, thinking about what kind of thing do I need, right? And there are different brands and different price points and different pursuits that you would have with this device. What's it going to be used for? Yeah, like, I think an NPU makes a lot of sense for a lot of knowledge work type work, right? And if for no other reason than to get the most out of your operating system. We know from our friends in Redmond that Windows is going to start baking AI features into itself that it intends to run on the device, right? This stuff is expensive to ship to the cloud and back every single time. So some of the stuff like background blur on a Microsoft Teams call, speech to text, all of this stuff is going to look for a home somewhere on your device. And guess what? CPUs, the workload hasn't gone anywhere. That CPU is still going to have to do all of it's the workhorse. It's still going to have to do all the things it's always done. And now, if you don't have an NPU or a GPU, it's also going to have to support this new kind of workload. So that's one thing to keep in mind, where if you decide no NPU, no GPU, well, gosh, your CPU better have some slack in it. It better have some bandwidth. GPUs, I like to talk about the birth of a new persona. And persona, again, being a word that people in our world think a lot about, right? The data scientist persona is something that, like, an IT decision maker is constantly thinking about. Like, what does that persona need? And you really have the birth of a new persona with all this AI stuff, because you have people like myself who are not formally trained in that way as engineers, but who know enough to be dangerous. And now, with the right kind of device, I get supercharged. And with the wrong kind of device, I get throttled. So this is very much a productivity gains question. And that is sometimes really hard to quantify. So knowledge workers, NPU makes a lot of sense. Knowledge worker plus, maybe like these new persona at the edge of a dev and a kind of regular knowledge worker. That's me. And I would ask for something like a discrete GPU, because I know that's going to last me. And also, if you want a device that you can use to train AI workloads during the day and give to your kid to play Fortnite later, like, GPU is probably the way to go. So there's a dual use argument to be made there.
Yeah. And just to add to what Ish is saying, I would classify them today. And again, you have to keep in mind this is rapidly evolving. But today I could classify devices into three categories, right? You have the essential AI PCs, which have what I, for lack of another moniker, call them entry level NPUs, right? Think 10 to 15 tops or trillions of operations per second. And those are great for basic workloads coming from, as Ish alluded to earlier, your background blur, your voice correction, and other optimizations, offloading that from the CPU so you have a much better experience. And they can accommodate smaller models like up to maybe 1 to 3 billion parameters. But once you get there, now you're bringing workloads back to the CPU if you go beyond it, right? So that's probably the limit there. Then in the second category is maybe slightly more advanced AI PCs with more performant NPUs or state-of-the-art NPUs. Today, that's about 40 to 50 tops. And that really brings on-device AI into focus. Right now, you can actually bring custom workloads, perhaps run up to 9 to 10 billion parameter models for custom in workflow embedded use cases across a variety of verticals. In addition to the Copilot Plus features, which run locally on your PC that is talked about, right? So this is again a very nuanced, difference here. Microsoft's Copilot branding refers to everything that runs in M365 in Azure, right? And that's all cloud-based, subscription-based, largely. That's their Copilot brand. Copilot Plus is everything that runs locally as part of the OS itself. It's part of Windows, no extra charge, and they can, as he said, Ish said, is going to continue. Microsoft's going to continue to add more and more capabilities that run locally on the PC. So for you to harness those capabilities and not lock yourself out of those capabilities in the future, you definitely want a PC, an AI PC with at least 40 tops on the NPU today, right? That is my recommendation for the for the knowledge workers and the the most common use cases. And then the third one, it's kind of self-explanatory now. It's your high performance PCs. Those have your high-end CPUs from the CPU suppliers, right, which are much capable of much more performant single and multi-threaded processes. And then you have those augmented with discrete GPUs and discrete NPUs. Now you're talking about the persona that Ish talked about is you're starting to create that separation between your power users, your AI and ML and data scientists that can really now do data crunching and work with models right there on the device itself. So that's the three-pronged categorization
I
today
thought
for
I
AI
was the
PCs.
recovering consultant, and here's Shirish with his three buckets, right? Like BCG would be proud. One thing, John, I want to add to that is like, we're not a walking infomercial here. And I know there's like a big corner of the internet, like, let's be real for a second. That's like, hey, like, I watched the NPU advertisement in the Super Bowl. Like, I watched the Copilot Plus PC ad with the zebras and the scientists in the forest, right? But like, really, what does it mean to me? And again, it's about this temporal mismatch. How long are you going to use this device, right? Oh, I'm skeptical of the features that this particular company is building. I'm never going to use any of those. Again, think about the future. Think about the things that are happening at breakneck speed, breakneck pace. That's what you have to be thinking about, that temporal mismatch. So even if it's not up to your tastes in this moment, there's something bigger to consider. And again, it's not about an infomercial. These are just the things that I would be thinking about if I were buying one device or if I was buying a million.
For my listeners who want to level up their AI career through hands-on learning, ODSC AI West, October 28th to 30th in San Francisco is the place to be. I know this conference well, and what sets it apart is that it's all about doing, not just listening. You'll gain practical skills by working directly with cutting-edge tools and frameworks in immersive hands-on workshops and tutorials led by some of the world's top AI experts. Beyond the training, ODSC AI West also brings the AI community together with hackathons, networking receptions, book signings, and more, giving you the chance to learn, practice, and connect all in one place. Use the code SUPER at checkout on odsc.ai for an additional 15% off your pass. That's odsc.ai. Yeah, for sure. It's an interesting situation here because you guys obviously do both work at Dell. And so it's easy to feel like it's infomercially, but simultaneously, everything that you have been saying so far is useful to me as somebody thinking about, I mean, like, we on the show, we have a lot of different kinds of episodes on different kinds of topics. A lot of the time we're covering open source software, but you can't, you need your software to run on something. And and there's no open source hardware. You can't just download free hardware
Yeah. There's no
and have
GitHub
that
pull you
going.
can go
So
do. Yeah.
exactly. So there's some, by its nature, it has to be in some way kind of a bit of a commercial conversation, but hardware is something that you need for any of
Exactly.
the work that we're doing, any computing. So speaking of software and kind of the experience of using these devices. So if we're talking about having NPUs on our machine, having GPUs on our machine, having CPUs, and I want to dig into CPUs in a bit briefly as well. So I'm going to get your subconscious thinking about
Yeah.
about CPUs in general. But when we have, I think it's pretty easy, at least in terms of utilization. The CPU is the most general of all
Mhm.
these devices, and so I think we're used to, probably most listeners are aware that CPUs are doing the most kind of general work, running your operating system. And what I'm trying to get to here is it sounded pretty obvious from what you're describing that in the future, or maybe even today, Microsoft will have automatic support when you're using, say, Windows for NPUs. So
Mhm.
you're talking about Copilot Plus features, text to speech, any of these kinds of things. They'll look for the best device available for running those, and if
Mhm.
there's an NPU on the machine, it gets sent there. So I get that for the kind of click and point operating system experience. But if I'm a data scientist, if I'm a software developer, if I'm an AI engineer, then what do I need to do to engage those resources?
Yeah.
What is my experience like? What software do I use to get access to NPUs, GPUs, or be
Mhm.
making the decision? How does all that work?
Yeah. Multi-part answer, I think, here. The first part answer is it's nothing you've not done before in some ways. GPU acceleration has been around for some time, right? You mentioned all the uses for the CPU. Like, yeah, I know of all of you and your 100 tabs that you refuse to clean and close. We know about you at Dell. We know you require some CPU juice. But GPU acceleration, it's been around. Solvers like Garobi have GPU support. CAD software, GPU accelerated. So the sort of tried and true methods of acceleration, the abstractions are sort of similar, right? And then you're going to start to hear about all kinds of funny name stuff. And it's really going to strike you as like, what is all this, right? You've got Llama CPP, you've got OLLAMA, you've got sort of to a lesser extent, CUDA's been around, but you've got this CUDA X layer now that sits in the middle. Like all of these things combine to have this plethora of stuff. And maybe not all of it is deployable at scale in like an enterprise environment. Like if you are a data scientist, sure, go pull Llama CPP and run a GGUF model, fine. You know how to do this. You will know how to do this. If all of these words are alien to you, 6 months from now, maybe John will invite us back and they won't be as alien to people anymore, right? But like the work that the folks at Unsloth are doing, the work that folks like The Bloke are doing. And these are all names you see on the Hugging Face boards of like these models getting rolled out. To land those on particular pieces of silicon requires that software layer. And if it's not a software layer, it requires sort of this abstracted API. Dell, and John, you opened this with, you are a devices company. That is what you are known for. And we know that that's our identity. To use the device to make the most of it, we've created something called Dell Pro AI Studio. It's a thing that lets you not have to worry about this as much if you are the developer of an application. I'll let Shirish talk a little bit more about Studio.
Absolutely. So I think that was very insightful-ish. I learned something from that too. So that was a great monologue there. I wanted to add
Monologue,
one
he
more thing.
says. Oh, God.
Sorry, cut that.
Shakespearean.
We gotta
No,
cut
we
that
are
one
we
out.
are not cutting that. That was perfect. Absolutely. That is in the episode. Mario, do not listen to the guests.
So yeah, I just wanted to add that the complexity of being able to bring your AI workloads and land them on the PC accelerators is not a trivial task, right? Ish painted a really vivid picture there, and it's not for the faint of heart today, right? So if you think about someone who's beginning their journey in, as an AI engineer, or who's trying to run um, AI locally on a PC, whether it's the GPU, the CPU, or the NPU, um, they have to make sure that they have the right format of the model. And if it's not the right format, they have to have the right tool chain to convert it to the right format. And that conversion process is different for every target CPU architecture, right? And IHV. So if it's Intel or AMD or Qualcomm or NVIDIA, you're looking at a completely different tool chain to go make that conversion. And then that it proliferates from there, because you're talking about one model, right? Now, that's not how models are typically. There are model families. So if you want to make your entire model family of, say, Llama available, and you want to quantize them or do LoRa's or something, now you're really creating some tremendous, you're creating a huge tree now, right? Massive branches. So that's a task that is daunting even for experienced practitioners. So with that said, that's why Dell Pro AI Studio became almost an imperative for us to create. And we focused on abstracting away all of that complexity, all right? And um, the focus being, how can we democratize access to AI on the device for the broader development community, so you don't have to be working directly with Intel OpenVINO and be 6 months into your journey there before you can actually land something on the NPU, because that's what it takes today, right? And more on Dell Pro AI Studio. That's the paradigm, right? Reduce complexity, go faster. I'll talk about some of the speeds that we've accomplished, right? So we did a POC with a partner of ours, Deloitte, and there's a white paper coming out on this pretty soon. We did a comparison of a use case that was built for on-device AI, and they'd already worked on it before they used Dell Pro AI Studio. And then we normalized it to a team that was just beginning their AI journey, right? And so we kind of looked at it three ways. And what we learned was, for the team that was just starting their journey with, say, Intel OpenVINO, it took them about 3 months to actually go from scratch to have an app that is fully integrated with a model that's actually running on the Intel silicon. And it took the same team with Dell Pro AI Studio about 4 days to do that. So, and that's not like a linear, simplification of time. That temporal concept is really, we just eliminated that engineering complexity for them. So that's the second reason why we built it, right? We wanted to democratize access for the developers at large to bring AI workloads to our PCs, and we wanted to make it quick and easy for them to land it on a variety of silicon. And last but not the least, we also put in, a excuse me, an API that actually is following the OpenAI de facto API standard for hosts. And so if you're running a web app that is pointed to either an on-prem workload or even a cloud hyperscaler workload today, but you're using that OpenAI de facto spec, you can just make a quick one-line configuration change, point it to the local server on a Dell machine, and you're done. It is now running on a local model that's running on your device accelerator. So that's a long-winded explanation for what Dell Pro AI Studio is, but hopefully that resonates with
It all sounds great. One thing that I think might be helpful to me and to our listeners is to understand. I realize that, as you mentioned, there are lots of kinds of personas out there, but is there kind of like a user story that you could describe for us, to kind of, so that we can visualize, so that we can imagine what it's like for us to use Dell Pro AI Studio? Like, I think I get the functionality. It allows us to take advantage of all these powerful devices for whatever kind of AI workload we have. But what does it look and feel like?
In terms of real life application, and this, John, your question is also super salient because it's also about the bigger conversation around why would you ever run a workload locally? Like, why would you ever do that to begin with? Like, as a data scientist, as a knowledge worker, as anybody, why would you ever do that? Right? Offline mode comes to mind, right? Like, if you want your AI based application to continue working, even when the person's on an airplane and has a lousy connection, guess what? You're going to want to run that workload locally. Reasons related to speed, cost, security, connectivity, all of these signals are the reasons why one might run a workload locally. And examples of those, John, models are not apps and apps are not models, right? The data scientist universe knows this, right? Like credit card fraud detection is the objective. Within that objective, there are many models doing different things. It's the same for local apps. Today, there are a lot of them like LM Studio, anything LLM, that make it easy and put a GUI on top of, I'm going to go in and I'm going to do AI work locally on my machine. Look through the app, abstract away the app, and start to think about you as a data scientist. What is the purpose of the thing you are building? That's what the GUI is going to look like. On the back end, the user doesn't care. Is it going up to the cloud? Is it going down to my silicon? The user literally doesn't care. They're going to care about the performance and they're going to notice that there's a difference, yes. But that's why there's sort of this routing objective around when you run workloads locally. And that's why Dell Pro AI Studio makes it as simple as a one-line config change. Instead of sending the workload up, you send it down. You just change where it's pointed at. And that's the whole point of what we've made. Shirish mentioned OpenVINO a couple of times. Dell Pro AI Studio is an extension of OpenVINO. Like OpenVINO's in there. We worked with Intel to bring this thing to life and to make it easy to use. And as are the OpenVINO twins from other people who make pieces of silicon, right? So the whole purpose of defining the use case, it's not about running something locally just to say you did. Although I enjoy that and I spend a lot of weekends doing it, right? It's also about when and why does this make sense? Am I forcing this down someone's throat because I want to? Or is there genuinely a reason this data-related workload, this AI-related workload, should happen on the device?
Gen AI and classic ML are great at solving a lot of problems, but they are not built for complex decision problems. Mathematical optimization is the perfect complement to these skills for decision-making at scale. Trusted by companies large and small, Gurobi Optimization is the fastest and most reliable optimization solver. To see the value of Gurobi Optimization with tons of real case studies and build the optimization skill set with tons of learning materials, head to gurobi.com/learn. That's GUROBI.com/learn. You talked about OpenVINO there and working on Intel with it, which is a great segue into a topic that I wanted to make sure we covered in this episode. So the Dell AI PCs that we've been talking about, the hardware we've been talking about in this episode, we've talked about NPUs, GPUs that are available on them. And I already alluded to this. I said that you should get your subconscious going. We've talked about the purpose of CPUs as being relatively general purpose compared to NPUs and GPUs. But I wanted to specifically, because we have experts like you on the show, I don't actually know very much about CPUs or considerations about them. So, for example, um, uh, Intel Core Ultra processors that were released in 2024, last year, there's this Lunar Lake architecture. What is the significance of that architecture, which I think is the standard now on AI PCs? What is the significance of that architecture for my listeners, for the data science persona?
Yeah, so I'll take that one. A little bit about Lunar Lake. So it was quite a different architecture in which you had memory on chip, so quite unique from Intel. And so with that integrated memory, you actually had very fast transfer rates, from processor to memory because it's, it's MOC. They are the first Intel architecture that supports 40 plus stops on the NPU. So, if you're looking for a Copilot Plus PC from Intel, with an Intel processor, you're looking for Lunar Lake. That's kind of the highest level, right? Apart from everything else, well, it's still x86 based, so there's nothing different there, nothing unique or different. It's not ARM, right? That was the biggest difference. The MOC is what allows for tremendous performance gains. And I will mention that the iGPU, the integrated GPU, also achieves some step function performance gains, wherein they're actually rivaling, or I would say exceeding, the performance of some of the entry-level discrete graphics cards.
Very nice. That was a clear definition as we've come to expect from you, Shirish. And now I do feel like I understand the significance of Lunar Lake architectures in particular, the kind of step gain efficiency improvements that you were describing there, like memory on chip. So I want to kind of bring all this together. We've talked about CPUs now most recently, obviously GPUs, NPUs earlier in the show. And we've also been focused on what you call client devices, kind of local processing, laptops, desktops. Let's talk about why all of this is significant in the Gen AI era. So, for example, at the time of recording, not too long ago, a couple of weeks ago, OpenAI released open source LLMs for the first time in a while. Earlier in this episode, we talked about llama models. So, what are the kinds of thing, those are, that gives us the capability to be taking these open source models. You were talking earlier in this episode about laptops that can have 109 billion parameter models on them. You're talking about desktop appliances like the GB10 that could have something even double that size running locally plugged into your machine. And so, in this brave new world where these kinds of gigantic, highly capable open source models are available, where we can be downloading them onto local devices, what are the kinds of circumstances where you'd recommend that versus doing something in the cloud?
Yeah, use case dependent. And I know that's a frustrating answer because it's the same question that a lot of Dell customers ask us. And to come in and to tell them that here's the formula you're going to use, I wouldn't be being honest with them, because when I decide to run something locally, it's because I've analyzed the situation, determined what it is I wanted to do, and picked local as the thing that makes most sense. Let's say I'm working on something that contains a lot of personal information that I don't feel comfortable putting into a cloud-based AI tool. Or let's say that I am subscribed to a cloud-based AI tool, but it's close to the end of the month. I've burned a lot of my tokens and maybe I don't have many of them left. All of those are reasons why I would turn to something like what you mentioned, John, right? The GPT OSS family of models. I think it's super telling that a company like OpenAI, which has to be very intentional about what it does and where it spends its very valuable human capital resources, chose as part of their open source launch to have one of the models be a smaller model. I think that is really telling because it tells me that in this agentic world that's coming, where it's not just chat back and forth anymore, right? It's like by the time you have your AI tool write you your 50th poem, you're kind of like over it. And it's like, all right, like data scientist or otherwise, what is the applied practical use of this tool? Like code gen, creating little applets to help you do the things that you do on a day-to-day basis, and it's not something you want to go subscribe to. Local is a phenomenal application of that, right? Like, so determining that I'm going to do my code gen locally versus in the cloud is a question of how much do I want to spend on it? How fast do I need it to be? How capable do I need it to be? For me, a person like me, that local use case makes a lot of sense. I'm not burning through tokens and watching my credit card, right? So it is a frustrating answer because it's about choice and that agency that you have to decide where to run what and when. All the way at the top of this conversation, John, we talked about, Windows versus Unix versus Linux versus et cetera, et cetera, et cetera. Choice has remained the theme here. Choice of chipset, choice of operating system, choice of local versus cloud. There will be a right tool and a right method at the right time. So I know that that's not the answer everyone wants. And it's always met with this crestfallen look in the room when we talk to our customers, because it's like, I thought you were going to tell me what the answer was. The answer is that this is hard. We got to do the work.
There were some clues in there, though. Things like data privacy.
Mhm.
Yeah.
Edge you in the direction of not doing things on the edge.
Yeah.
I'll add a spin to it. I think the other thing to consider is, apart from, I was going to bring up privacy, and you nailed it, John. That's an important consideration. We're seeing more and more of that concern, right? Like sovereign AI, enterprise AI, they're almost synonymous now, where customers, they're trying to get to initial value as quickly as possible to start their AI journey, right? Because they want to show outcomes, show value. And sometimes the answer is, let's just go to the frontier models in a hyperscaler environment, right? Because it's the easiest way. I don't have to scale up my team. I don't have to, invest a whole lot and increase my time horizon. I can get there quickly. But they're also trading off control. They're trading off, they're at risk of getting locked in to the ecosystem, and they're also trading off security, right, and privacy of data, especially IP, which is starting to become a big deal. And we hear about policy decisions being made across the world, right, that are changing things or putting guardrails on what governments cannot do. And then you have, of course, private enterprises that they have their own sets of concerns, right? And the regulatory compliance requirements that they have to adhere to. So I do think that from that perspective, if you think about cloud versus local, to me the answer is hybrid. Really, the future is hybrid, because it is not practical or feasible to move all workloads to the PC. And at the same time, you want optionality, because you don't want to be locked into just one type of node, right? You want to be able to run the right workload on the right compute engine at the right time. So I foresee there being intelligence in an agentic future where there are either basic ML classifiers or much smarter agents that are able to decide where a workload goes, and then just be able to use distributed nodes, right? Whether it's the PC fleet, a GPU cluster on a data center, or wherever. So I think that's the future, to be honest.
Most people have not thought about computation as a resource like this in a long time. Like as a token to be spent, as a dollar to be spent, like how many units of compute do you have? And now on YouTube, you see every which person stringing together 50 of the same device stacked all the way to the ceiling. Look at this node I made, right? There's a particular Formula One team that Dell works a lot with. Particular team that happens to be winning, I'll add. A particular team Dell works a lot with. And they are very big on sandbox experimentation. They're very big on like, I don't want to worry about, like, I just want to test something quickly. I have an idea, I have a hypothesis. And this is data science we're talking about. This is, thousands of points of telemetry being captured off of these cars, rows upon rows upon rows of data. I just want to see something real quick. I don't want to have to worry about, do I have to spin up my instance? Is there a queue? Are we like, just give me a device. Let me go look inside. But this file is much too big to open in Excel and scroll to row 750 to check a particular telemetry point, right? Like sandboxing is another big reason why this stuff on device is going to matter. And even if the rest of it isn't clear, experimenting with local AI to see if it is part of your workflow or if it is something that's useful to you, that's the only way you're going to find out. You got to do it.
Really cool. And as an F1 fan, it certainly is not a bad time to be affiliated with that particular team.
Nope.
Their dominance this season is pretty insane.
Yes. Powered by Dell.
Nice. I have one last technical question for you that I'd just like to squeeze in quickly. There's a big Windows refresh coming up in a couple of months in October. Well, I guess at the time of this episode release in a month. And so it sounds like a lot of people might need to be thinking about upgrading their hardware now, especially if they're using a PC. And so tell us a bit about this big refresh. And that'll be kind of where we end the episode. I'll ask you both for a book recommendation after, so you can start thinking about that in your subconscious. But otherwise, yeah, let's wrap up with this Windows refresh.
All right, so let me go first, and then Ish, we'll get your take. Since I'll keep it audience conscious. So let's talk about Dell Pro Max first, right? And if I even look at it broadly, just data scientists and developers, um, something to look forward to is the new line of PCs that are equipped with NVIDIA's Blackwell RTX Pro GPUs. Really game changing, I think, looking at some of the capabilities, right? You can run, Ish talked about CodeGen a while back. You can run a model like DevStroll Small, which is the 24 billion parameter one at FP32. You can run that completely locally on the RTX 6000 Blackwell GPU, which is doubling the memory for VRAM. It's 96 GB VRAM, which is allowing you to do these kind of models, work with these kind of models locally. The other cool things about these devices is, to think about the power that these are consuming. So these are triple fan cool designs. So massive thermals, investments in thermals and acoustics to give you that experience. So if you're the cue to your listeners is if you're trying to bring some of these newest SOTA, state of the art models and run them locally, and you try to do it on the previous gen product, chances are you either just can't do it, or if you're able to, depending on the model of choice, you're going to have, pretty much like an airplane on your hands, right? That's what it's going to feel like. So, strongly recommend your listeners to consider the newest line of performance desktops and laptops. One other thing I'll tell you is one of my colleagues was running some quick tests, and what he found was um, for a for like a video workload, right? Just think of like animation. They were working with a large studio, um, and they were trying to create based on previous artwork and shows content. They were trying to train a model that would keep the style consistency and be able to deliver sort of stage up the content in the same milieu. And so different, they were trying to create mock-ups with fine-tuned flux loras. And in the previous gen GPUs, it was taking approximately a week, and with the Blackwell GPUs, they're getting it done in about 3 days, right? So that's pretty measurable in terms of performance gains that you're getting. So just talking about that very specific persona, I would say take this opportunity to, with this Win 10 end of life, if you're looking for a new device, definitely look for the latest and greatest, because the gains to be had will set you up for, the next 4 or 5 years to come.
Excellent. I can't believe how you can reel through those technical stats seemingly without notes. Pretty mind-blowing, Shirish. Ish, how are you going to follow that up?
Yeah, I'm going to do this and I'm going to whack some people back in the head, right? Do not let this deadline pass you by, for the love of God. This is not a selfishly motivated thing that is coming out of my mouth right now. This is look, when operating systems age out, there's a reason they're aging out. There's new stuff coming from a security perspective, from a manageability perspective. If you have been procrastinating, please stop procrastinating, whether you buy a Dell device or not. Just please make sure you understand the gravity of an OS refresh and make sure you're not hanging on to something that might be best retired in its 17th season, right? So that's, I think the only thing I can add to Shirish is like, hey, like October is here. Like it is no longer this big thing in a future horizon. Like you need to solve this problem now because it is a problem.
Nicely said.
Yep.
And by the way, for our listeners, so Ish, when he was hitting you on the side of the head, he was flicking his microphone, which he probably presumed would create some kind of like loud sound or whatever, but there was nothing.
Oh man.
Just kind of a just kind of a pause.
Yeah.
Yeah, fantastic.
Dang,
Well,
noise
this episode,
cancellation.
yeah, exactly. It
Too
would have been
good.
something like
Too
that.
good. The AI features have gotten too good, guys.
Yeah, yeah. Uh, Ish and Shirish, this has been a fantastic episode. But yeah, before I let you go, I would love to get a couple book recommendations. Ish, let's go with you first.
There's a great book called Deep Learning Illustrated, John.
Aw.
John's book, of course, being a great one. I took a course at Sloan called The Analytics Edge, and it took me as a person from, didn't know anything about anything in terms of data science, and it gave me what I thought was a great starter foundational toolkit for a business and strategy oriented person to become familiar with applied data science and how to use it in a
My book?
no,
No,
the
no, no. You're
Analytics
talking about
Edge.
the
Yes, the
analytics edge
Analytics
group.
Edge.
So I thought
Yes,
you like so that's like a course that people can take.
it was.
I
Yeah.
thought maybe you were saying that like my book was like the companion text for that course or something.
No, that I honestly it should be though. Having looked at both, I think it should be. So we should have that conversation and see who we can bother over at MIT to get that used. But no, it's about feeling like this is within reach for a lot of people. You don't have to feel like AI and data science in 2025, like, gosh, there's these 16-year-old wonder kids who are out there, like, for me to start now, mid career, trying to learn this stuff, like, why even bother, right? So, on the technical side, like, go check out the Analytics Edge. It made me a somewhat competent human being, which, I was less so before I read it and before I took the course. The second thing I'll say is, like, I have a renewed interest in fiction in this world because what these models are doing for creativity and what these models are doing for like content and storytelling more broadly is like a really fascinating element to this that I spend a lot of time thinking about, which is if everything is derivative of something older, like, is that really a new phenomenon or has it always been that way? So I'm actually blazing my way right now through the Reacher series, like the Jack Reacher series, and inspired by the Amazon show. I had never actually picked up those books and read through them. And as I'm reading them, I'm also thinking about, gosh, what is the future of fiction going to look like? So that's my plug for Lee Childs.
Very nice. I like the fiction recommendation there. And just so that I'm understanding, so the Analytics Edge is
Mhm.
both a course and a book.
Correct.
Uh, and so, okay, yeah, great, perfect.
And we'll take a look at that, John, after we hang up, just to make sure that I'm not making something up. But yes, is the
Yeah,
short answer.
we'll have something in the show notes for you
Yeah.
listeners. And Sharish, do you have another book recommendation for us? I know
I
we,
do. I'm
yeah.
actually reading Seven Powers by Hamilton Helmer. Fantastic. I think it's a very fresh take on business strategy and, you know, sustainable, long-term, profitable companies. So I highly recommend it. I'm still reading it. I'm not done with it, but it's brilliant. The second one is actually one that I picked up based on your recommendation. It's the hands-on machine learning guide by Aurelian, which I haven't started yet, but it's sitting on my desk. So it's going to be my companion as I revisit some Python after years. So
Yeah, so that will actually be so your this episode that we're filming right now, it will be a week after. We just had Aurelian Giron on the show. He's the best-selling machine learning author of all time with his hands-on machine learning series. And yeah, so thank you for that nice cross-reference there, Shirish. Fantastic. Thank you both so much for being on the show. This is another wildly informative episode from you, Shirish and Ish. I really enjoyed getting to meet you as well. You do have so much color to add, and you can't hide that intellect. I'm going to tell your mom that you do have it.
Coming from you, John, that's going to mean a lot. Also confirmed, Analytics Edge is a book, not making it up. I wasn't hallucinating the years 2018 through 2020.
Nice. All right. Thanks so much, both of you. And I wouldn't be surprised if we're hearing from you again on the show sometime soon.
It's been awesome, John. Thank you.
thanks, John. Fantastic.
What a fun and informative episode with Shirish Gupta and Ish Shah. In it, we covered how Windows is used by 64% of software developers, and WSL2 bridges the gap by running Linux kernels directly on Windows. We talked about how with modern discrete NPUs, we can locally train models of up to 200 billion parameters, how NPUs are optimized for AI workloads with superior performance per watt for battery efficiency, while GPUs offer higher absolute performance and scalability today. And lots of other considerations around cloud versus local AI work and what hardware you might want to use for either situation. As always, you can get all the show notes, including the transcript for this episode, the video recording, any materials mentioned on the show, the URLs for my social media profiles, as well as my guests at superdatascience.com/921. Thanks, of course, to everyone on the Super Data Science podcast team, our podcast manager, Sonia Brevich, media editor, Mario Pombo, partnerships manager, Natalie Jaisky, researcher, Serge Massis, writer, Dr. Zara Karshe, and our founder, Kirill Eremenko. Thanks to all of them for producing another super episode for us today. For enabling that super team to create this free podcast for you, we're deeply grateful to our sponsors. You can support the show by checking out our sponsors' links in the show notes. And yeah, otherwise you can help us out by sharing the episode with people who would value it, reviewing the episode wherever you listen to or watch podcasts. Subscribe if you're not already a subscriber, but most importantly, I just hope you'll keep on tuning in. I'm so grateful to have you listening, and I hope I can continue to make episodes you love for years and years to come. Till next time, keep on rocking it out there, and I'm looking forward to enjoying another round of the Super Data Science podcast with you very soon.